Hello friends, welcome once more to class online. My name is Dami, and in this video we shall be dealing with the aspect of physics that has to do with AC circuit. We have some questions in AC circuit and some questions in electromagnetism that we would like to look at. This is Waec Physics 2013 question 36 to 40, and we shall be blasting. Don't forget, if you learn something from this series and you want to get more content from us that will better help you understand physics, click on like button. We have a lot of videos and content to send to you that will clarify a lot for you. Now let's get to the question now. The region around a magnet in which magnetic force can be experienced is known as what? Now this is actually SS1, and this is actually very easy. Now an area around a magnet where you can feel the force of the magnet, is it declination or flux density or field or flux? Now those forces moving from the magnet around is flux, but the area is called the field, and the answer is simply magnetic field. Now these are the fluxes. These are actually line of force going around a magnet. These are lines of forces or flux moving around the magnet. But this area around the magnet under the influence of this flux or these forces is called the field, the magnetic field. And that's why if you bring any magnet around this field, it might be attracted to this magnet. And that is the reason why magnets attract each other, is because they are in the same field. So if a magnet is standing, it has a field around it. If you bring another magnet to that field, it will pull the magnet to itself if the poles are facing each other in the right way. So that is the way they work. So the field is the area around a magnet, and that is the answer. And that is the answer for number 36. Let's check out number 37. In an AC circuit, when the supply voltage frequency is equal to the resonant frequency, the current what? Now there's one thing to notice in this question. It is actually very simple, but you can see there's something called resonant frequency, and at resonant frequency only one thing happens: the current is in phase with the supply voltage, and that is it. So now let's check it out. Let's check it further. I kept a note here. You may also notice that at the maximum current through the circuit as resonance is limited only by the value of resistance, a pure and real value. The source voltage and circuit current must therefore be in phase with each other at this frequency. So that means the voltage and the circuit current must be in phase, and that's the answer. The source voltage and the circuit current are in phase, and that's what we call resonance. That means two things are in the same phase, and that's voltage and current. Voltage and current are in phase when we have resonant frequency. Now then, the phase angle between the voltage and current of a series resonance circuit is also a function of the frequency for a fixed supply voltage, and which is 0 at the resonant frequency. Then VI and VR are all in phase with each other as shown below. No, actually I didn't show. Now this is the picture. The current and the voltage, the current below, that's the purple one, the voltage is in blue. Two of them are in phase. You can see the way they move. They are actually in phase. At resonance, you can see this more in phase than this. They are actually in phase, and this is showing you the phase, that whenever it is resonant frequency, the voltage and the current are actually in phase, and that is the answer to number 37. So the answer is the current is in phase with the supply voltage. D is correct. Number 38 says the energy stored in a simple cell is what? Now if you have a battery, what is the energy in that battery? Is it electrical energy? Now it comes out like as electricity, but the energy stored in that battery is what? Is stored in what form? That simple cell is a battery. The energy in it is stored as what? Is it in electrical form, or nuclear form, or thermal form, or chemical form? Now the answer is very simple. This is a battery. You can see the energy is coming out as electricity and powering this bulb, but the energy is stored as what? I kept a picture here just to help us. It is stored in this picture is called an electrolyte, and it is chemical. This picture can be found in chemistry too, because this is chemical. This electrolyte is like what you have in your car battery. You know, we have what's it called? Acid. Car battery acid. That acid is in liquid form, right? And this is the electrolyte or the liquid. So it is chemical, it is stored in chemical form. So energy inside the battery is stored, not the one coming out. It comes out as what electrical, but it is stored as chemical. And that is the answer to that question. Please don't forget. And that is the answer. Number 39 says, which of the following conditions occur at resonance? See the word resonance again. Okay, in a series RLC circuit. Now, is it impedance equals resistance, or current is maximum, or reactance is maximum, or current and voltage are 90 degrees out of phase? They are not out of phase. They can be out of phase when it is resonance. So they have to be in phase. Like we said before, the word resonance frequency is when the voltage and the current are in phase, or the same phase, right? Now, but another thing occur that we did not state before, and that is this. Now, during resonance on RLC circuits, this occur. Inductive reactance is equal to the capacitive reactance, and that is the first thing that occur. And I think that's one of our answer. Impedance equals resistance, like you have it here. Impedance equals resistance. Let's see. Total impedance of circuit becomes minimum, which is equal to R. That's resistance. Okay, that is Z is equals to R. So it is actually, they are actually equal. So that makes what option 1 correct. Impedance equal resistance. It is actually very correct, and that is shown by the second option. Total impedance of circuit becomes minimum, which is equal to resistance. So Z, which is impedance, equals resistance, and that makes that correct. Then circuit current become maximum, okay, as impedance reduced. So current becomes maximum, and that is also correct. So 1 and 2 are correct. Then the next one is actually reactance is maximum. Is that true? Let's see. Reactance, okay. Then voltage across impedance and capacitor cancel each other out. So voltage across resistor equals voltage. That's the natural voltage, supply voltage. Then since net reactance is 0, circuit becomes, so reactance is 0. Net reactance is actually 0, and that one that says reactance is maximum is wrong. Net reactance should be 0. So the only answer that is correct in that option is actually 1 and 2, and that makes option A the correct answer. Current is maximum as resonance, and impedance equals reactance. Okay, also current and voltage are in phase, not out of phase, like we have seen before, and that is the answer for number 39. Number 40 says an electric motor converts what? Electrical energy to mechanical energy, mechanical energy to electrical energy, mechanical energy to sound energy, or electrical energy to thermal energy. This is an electric motor. You might have seen it before. If you have not seen it before, it is used in pumping machine. It helps to pump. So all pumping machines use motor, and anything that roll at home in your house use electric motor. Like your fan use electric motor, your blender use electric motor. Anything that roll cannot roll without a motor or a rotor. So now, but motor converts what energy to what energy. Now let's check it out. An electric motor is an electrical machine that converts electrical energy into mechanical energy, and that's the answer we are looking for. Now, electric motor gets energy from what? Electrical. Like when you want to start your fan, you have to plug it. You are not plugging the fan, you are plugging the motor. The motor in the fan is the one that gets charged and roll. It has a shaft. This rod is called shaft. So this rod is where the fins of your fan are hanging. So when you plug the motor, electricity comes through, and this shaft begin to roll. As it begins to roll, it starts spinning the fins of your fan. So it converts electrical energy that you plug in, that you send in, into mechanical or machine energy. That's rolling energy. That's mechanical energy or machine energy. Note the word mechanical came from the word machine, and that is it because a motor itself is a machine. So it changes electrical energy when you plug it into mechanical energy, and that is the answer. Electrical energy to mechanical energy, and then you will see the fan blowing on you, and you will be like, wow, this is fresh. And that is the answer for number 40. It changes electrical energy to mechanical energy. Why the opposite of motor, I must state it, is actually that which changes mechanical energy to electrical energy, and that is generator. The opposite of electrical motor, please note, because you might be asked, I've seen it before in the past that say that what is the opposite of electric motor? You know, electric motor changes electrical energy to mechanical, but a generator changes mechanical to electrical. Why is it mechanical? You have to pull it first, and that's machine working, then it now produces electrical. So gen changes mechanical to electrical, while motor changes electrical to mechanical, and that is the answer. So the opposite of motor is generator, and that is the answer, and that is the end of this video. Don't forget that if you learn something from this video and you want to get more content from this video from us that will better help you understand things, click on like button. We have a lot to share with you. Until we see you again, guys, take care of yourself and bye for now.